Hello everyone. So good morning and welcome back to the live session of doubt lectures on engineering mathematics. And I think we have already done 5 lectures on this so far. And this is our 6th lecture and 3rd lecture for the engineering mathematics. Sorry, 3rd lecture for the calculus. And so far we have, like in calculus, so far we have seen limits, continuity, differentiability in the first class. And then we saw Maclaurin's and series, all the series, Taylor series and everything in this previous class, the last class. And today we are going to discuss the evaluation of definite and indefinite integral. Apart from that, we will also discuss applications of integration, right? So application of integrations like length of the curve, volume, or maybe area enclosed, like all those things, right? So meanwhile everybody is joining, I expect, like, for people who are already there, they can share the link. Good morning, Kirti. Yeah, I see you there. So meanwhile everybody is joining, we can also share the link with your friends so that we can have more interaction in the class, right? And with this session we'll be like covering the part where we'll be like sure that we can confirm to solve the integrations part. But apart from that, the main intention of this session, I'll say, is we expect questions on this topic, no doubt. And secondly, this is something we have already done in our 11th and 12th. So there are a little basics is also expected from your end, so that a little basics is also expected from your end. And is there any problem? Am I audible, everybody? Is there any network issue, connection, anything? Because I don't see myself live. Yes, sir. Lokesh, Kirti, right. So, okay. So I'm audible and I'm clear. The video is also clear, right? I don't know, there was some interruption. So what I was saying is, apart from like few things we'll be obviously discussing, but there is an expectation, a prerequisite from your end, so that you also have a basics of integrations which you have already done in your 11th and 12th. I think mostly in 12th class, right? And this is required in your like technical subjects also, and apart from that it will help you in the further topics of the calculus. Like we are, after this we'll be moving into vector calculus, right? So it will be required. So that is why you can take it as a basics, you can take it as a revision, or you can take it like they are asking the question, so we have to complete it. Otherwise this is something we have already done in your like in your 11th and 12th, right? So let's start then. And we are all, like Lokesh and Geeti are already there, so I know like you all have already logged in and everything, registered yourself, right? So let's move to the lecture, live doubt lecture lesson, and we can start with the questions. Yes, so let's see. Indefinite integration, definite integral, and application of integration. There are like these 3 topics we are going to cover today, right? And let's start. The first question which we have from Civil 2017 is actually, you'll say, indefinite integration, because we don't have any limits here and we have to solve this, right? So let's see this. It says that within this interval of minus infinity to infinity, this f of x is defined and we have to find g of x. What is g of x? G of s is integration of f of x, right? G of s is integration of f of x. So this is your f of x. Now if you see clearly, as per the property of this exponential functions, we can like split it into, like, let's say we are writing it as e to the power of minus x into e to the power of minus e to the power of minus x. Yes, we can write it like this. And if you are writing it like this, let's say that this thing is like, we are substituting it and we are taking it as minus e to the power of minus x as t, let's say. So in that case, if you are differentiating on both the sides, we'll get e to the power of minus x will give you minus of e to the power of minus x dx is equal to dt. So this minus and minus gets positive, so it is minus x dx equal to dt. So what we are trying to do is, we are trying to solve this integration using the property or using the method of substitution. And in this method of substitution, if you see, like we said, this is f and this f is already having e to the power of minus x. So while integrating e to the power of minus x into e to the power of minus e to the power of minus x dx, this term dx and this e to the power of minus dx can be together taken as dt. That is what we have written here. And this e to the power of minus e to the power of minus x can be taken as simply e to the power of t, right? Because we have taken minus e to the power of minus x as t. So this entire thing is t now, and this becomes dt. So this is very simple. E to the power of t, the exponential will be e to the power of t only, and this is nothing but e to the power of minus e to the power of minus x. Correctly said, Lokesh. The B is the answer, A is not the answer, right? So B is the answer, right? So it is all about substitution. The major questions you expect in integration part in this, like in the gate examination, comes from the substitution method, and otherwise if it is coming, it is coming from the by parts. These are the major methods. Otherwise you can expect other things also, which you have already done, right? So B is the answer, right? Let's move to the next question then. This is also substitution method only. Same, but it is definite integration, right? So let's see, we can do it whichever way we want to solve it. But let's say we have to integrate this dx divided by under root of 1 minus x. So there is a radical term here, and what if we try to take this 1 minus x as t? Because a simple radical like a term of 1 by root 2 can be integrated, right? It is t to the power of minus half. So 1, I'll have to check what is the answer. Answer is, it's not 1. It's not 1. So let's see. So in that case, if I am taking 1 minus x as t, this minus dx will become dt, and in that case also this x has a limit of 0 to 1. So as per that, t will have a new limits, and t is 1 minus x. So 1 minus 1 will become 0, and 1 minus 0 will become 1. So in that case, this I can be written as, the limits changed will be 1 to 0, and instead of dx we'll write minus dt. So minus dt divided by under root of t, right? So under root of t. Now what we can do is, the property says if we have to change the interval of integration, what we can do is we can take a minus. So this minus and this order of integration from 1 to 0 can be interchanged, and we can write it as to be 0 to 1, 1 by root t dt. Minus 10. 1 second. Kirti. So 1 by root 2 is like t to the power of minus half, and the integration will become t to the power of minus half plus 1 divided by whatever you are getting. So minus half plus 1. So this is under root t by 1 by 2. So this is t under root, the limits are 0 to 1 divided by 1 by 2. So in that case, this is 1 by 2 becomes 2, and t to the power, like when t is 1, so under root of 1 minus under root of 0, and this will become simply 2. So 2 is the answer. Kirti, minus 1 is not the answer. Low case, yes, the answer is 2. So did you see that with the change of terms, like 1 minus x was taken as t, the intervals, the limits will also change. But in case you have any confusion in the change of the limits, like instead of 0 to 1 it became 1 to 0, one thing which you can do it is you do the entire indefinite integration and substitute t back to 1 minus x. So if we have this under root of t 1 minus 2, instead of this you again write it back as 1 minus x and take the limits. So I won't put the limits directly because I have changed some of the integration properties, like this minus was taken and interchange of this thing was done. So I'm not doing it here, otherwise it will be wrong. So what my point is, it's not like in between, I have already done something else also. So what I'm saying is, in case if you have any confusion with substituting the new limits, what you can do is, after the substitution method is done, after this indefinite integration is over, what you can do is you put that term back, like instead of t you put 1 minus x back and take the same limit 0 to 1. So that will be lower and upper limit and like that. So you'll get the same answer. The answer is 2 in this case. It's not what was that, minus 1 or 1 anything else. It's not that, right? So let's move to the next question. Yes. Again, it is a substitution method only, and something to take is sine inverse of x here, right? So we have this sine inverse of x if taken to be t, dx by under root of 1 minus x square becomes dt. And if you see, we have this dx and under root of 1 minus x square also. So together this can be written as t. So what I'm trying to do is here, I won't substitute this new limits. I'll keep it like that only, and then again I'll come back and then substitute and I'll solve it. I'll do it both the ways. So this integration, let's not talk about the limits now. And sine inverse of x, which we have taken as t, so it is going to be t square, and this dx by under root of 1 minus x square. So it is sine inverse of x square, and this thing entirely can be taken as dt, and this is nothing but t square, right? So that is what I'm trying to do is, that's it. So now the integration becomes t cube by 3, and I'm substituting back my sine inverse. So it is sine inverse cube by 3. So the limit was, like, let's say it is I1, because I'm not putting the limits in. It is let's say it is I indefinite, right? Indefinite. This is ID, this is definite. So I'm putting the limits, sine inverse cube by 3, the limits are 0 to 1. So sine inverse of 1. Sine inverse of 1 means how much? Sine inverse of 1. This is pi by 2, because sine pi by 2 will become 1, and sine inverse of 0 is 0, because sine of 0 will be 0. So this is nothing but pi by 2 cube divided by 3. So this is pi cube, 2 cube will be 8, so 8 into 3 will be 24. So we have this option, A option. So A is the answer, pi cube by 24. And what if, A option, correctly said, A option. What if we are trying to put the limits, right? I'm doing it otherwise also. So we had this limit for x from 0 to 1. So this t, which is sine inverse of x, so sine inverse of 1 will be pi by 2 and sine inverse of 0 will be 0. So if you are doing it directly, you can put the limits at 0 and pi by 2. So you have to put this limit here, 0 and pi by 2, without getting back to sine inverse of x. Then also you'll get the same thing, right? You'll get the same thing and you'll get the same answer again, right? So it is up to you. If you have any confusion putting it back, like putting the new limits, you can substitute the parameter back to the original and then you can put it, the limits, right? So the answer is A. Let's say this one. This will be like requiring the property of definite integration. Of course, you can solve x into cos square x as indefinite integration, but like you'll put indefinite integration, then you'll like integrate it. Maybe you'll split this cos square x and then you'll do it. But what we can do is we can also use the property if I is from 0 to pi x cos square x dx. We can put the property of, instead of f of x, we can write it to be f of a minus x, for which case if it is integration is from 0 to a. So 0 to a is equal to pi. This is a equal to pi and 0 is already 0, right? So what is f of x? It is x cos square x. B option. This is pi square by 4. Yes, B is the option. So in that case, what you can do is pi minus x, and cos of pi minus x is nothing but minus cos x. But minus cos x is nothing. If it is like square, this will come back to cos square x because it is square of minus of cos x. So what we can do is we can write it to be 0 to pi minus x and cos square x dx. And if you see, from this I and this I, if we are adding both of it, this x cos square x and this minus x cos square x will get cancelled, and what we will be left is 2y is equal to, and let's say take this common pi outside, 0 to pi cos square x dx. So you have to integrate this, and we also know the formula 1 plus cos 2 theta is equal to 2 cos square x. So you can write this to be pi 0 to pi 1 plus cos, this is x, 2x by 2, right? So now it is very simple. You can integrate this and you can get the answer also. Yes, B is the answer. Lokesh, A was, I think, was the previous one. So I think Lokesh is still doing it. So 2i becomes pi times of, so what is 1 by 2? Let's take this 2 also outside. 1 dx will become x and cos 2x will be plus sine 2x by 2 for the limit of 0 to pi. So what we can do is the sine 2x with the limit 0 to pi. So sine 0 will be 0, sine 2 pi will also be pi. So let's forget about calculation of this term, simply write it 0. And about x, this will be simply difference of the limits. So this is pi by 2 into pi minus 0, so it is pi. And for this 2, I am taking this side, so it is pi square by 4. This is the answer, right? K pi square by 4. B. B was what you said, right, Kirti? Yes, B is the right answer. So this is also done. Let's move to the next question. Try this. Okay, this is 1 marks question. So obviously we don't have to spend so much time here, and we'll like put some of the results here, conclusions here, and I'm telling you what is it. First thing is, like the sin x by x integration, it is not possible just like that, like using the common methods like substitution or maybe by parts or some trigonometric manipulations. It won't happen, right? The result, some of the results which you can use is from 0 to infinity sin x by x is pi by 2. You may get direct 1 marks question on this, so let's come to the results on it, right? Or if it is minus infinity to 0, sin x by x is also, yes, pi by 2. Yes, Kirti, it is B option. Otherwise it is from minus infinity to infinity sin x by x, take it pi. Also this integration, so 1 by 1 plus x square, this is a direct integration. The integration will be tan inverse of x for the limit 0 to infinity. Now this is an improper integration because you cannot take x to be infinity. There cannot be anything like that. But what you can do is x tends to infinity. You can consider that. And you know that tan inverse of x tends to infinity will be pi by 2. If you remember the graph of this, it will be something like this, tan x. It will be something like this. So this is at pi by 2 and minus pi by 2. So you can see that this x tends to infinity comes at pi by 2. So this is pi by 2 and 0 is for 0. And this result which we are directly using is this one, pi by 2. So this is pi by 2 and pi by 2 overall, pi. So B is the answer. You can use these results directly. Of course, you can find it, and using Laplace transform will be the best method to find the integration. But we can like keep it aside now. Let's see this one. Before solving this, I'll have a different method or different view on this. The thing is, this x square and cos x cannot be mixed, right? So in that case, the integration of uv can be done as D answer. I'll have to see. It is a minus 2 pi. So uv, just look at here. The integration of uv can also be done as u dash into integration of v minus, sorry, first one will be like that only, minus u dash into double integration, like double in the sense integrating twice, plus double integration, double differentiation, and third integration, then again minus u, let's say third differentiation and fourth, and so on. You're getting my point? So in this case, this x square cos x, we are taking this as u and this as v, right? Because it will require more number of by parts, so you can do this. And in this case, what we will get is I is equal to, like u is equal to x square. So the first term will be x square and the integration of v. So cos x integration is sin x minus differentiation of x square, which is 2x, and integration of sin x. So integration of sin x is minus cos x, and then plus differentiation of 2x, so 2, and integration of minus cos x, so it is minus sin x. And for all this, you have to put the limit 0 to pi, 0 to pi, and 0 to pi, right? Apart from this, what you can see it here is sin x with x square. So sin pi will also be 0, the upper limit, and sin 0 will also be 0. So forget about this, whichever is as a coefficient. So sin x, sin pi and sin 0 is going to be 0. So this entire term is going to be 0. Similarly, this is also having a sin term for pi and 0. So this will also become 0 no matter what is this constant or whatever, right? And we are left with this term. Out of this 0 will make this term 0. So we are only left with only higher limit or upper limit of this term. So minus and minus becomes plus, and 2x, so x is pi, and cos pi. So cos pi is minus 1. So this becomes minus 2 pi. So minus 2 pi is the answer, option A. Yes, Lokesh and Kirti. So minus 2 pi is the answer. So did you see, if you are trying to like, obviously we are doing it by parts only, but if you are trying it in the conventional method, you'll be doing it like twice, 2 times, and then you'll be substituting one by one. So instead of that, you can do it in this manner. You can also do some of other things like this. I'm giving you one indefinite integration. Let's say the indefinite integration is for x square e to the power of x dx. Check this one. Not giving the limits, it is indefinite integration, let's say, and we have to integrate it this way. So again, what you can see is, you can take this one as u and take this one as v, and of course there is a good thing about v, that integration of ex will always be e to the power of x. If it would have been minus x, then there would have been changes of like sign alternatively. So the integration is going to be what? U square, the first one is u, so this is x square, integration of e to the power x remains like that, minus differentiation, so 2x, integration of this, it is e to the power x, then plus differentiation of this as 2, and integration of this is e to the power of x. This is also called as Bernoulli's principle norms. Yes, you can see this, because what you are doing is, you are like taking it to the nth term, right? So again, what you are doing is, in the same method, in the same manner, you are doing it here also. So some of the time it will be of good help, so that you won't, like, you can do it easily and you can save some time, right? Okay, so this was indefinite, but fine. Let's see this one. Integration of sine cube x, sine cube theta in this case. So what you can do is, in all such trigonometric terms where you have sine and cos both, depending on the order of it, we'll have different types of like approach, but overall being same. So the sine cube d theta, if it is d theta, can be given as sine square theta into sine theta d theta, and then let's take one substitution as cos theta is equal to t. So if cos theta is equal to t, minus sine theta d theta will be dt, correct? And again, this sine square theta is 1 minus cos square theta, so I am writing it as 1 directly 1 minus t square and minus dt. Getting it? Because if cos theta is t square, sine square theta is 1 minus cos square theta, which is 1 minus t square. Clear? Now you have this integration, and of course there are limits from 0 to pi. This is 0 to pi. So now what you can do is, let's say, let's not put the limits now, we can put it at the end also. So this minus t, this is going to be t, like considering this minus on both the terms, this is t square, so it will be t cube by 3 and minus 1, so minus t. If you want to put the limits in terms of t, we have theta as 0 to pi, and then we have t, which is cos theta, so cos theta, cos pi will be minus 1 and cos 0 will be 1. So in that case, what we can do is, we can put 1 here and minus 1 here. You can check the value. What is it? If you would have, I'll extend it. if you have already, like if you are substituting the values here also, 1 and minus 1, I'm taking it here. If you see this 1 and minus t square, both are even function. Of course, you can solve it here also, but what I'm trying to do is using one more property. So if both the functions are even, from minus a to a can be given as 2 times of 0 to a, right? So for this minus and this term, I'm changing the interval and I'm making it minus 1 to 1, 1 minus t square dt. And then I'm like considering both the terms to be even, I'm writing it as 2 from 0 to 1, 1 minus t square dt. I can do it this way also. So I'm giving you both the approach and you will have to solve it. So in this case, what you can do is 2 times of t minus t cube by 3, and the limits are 0 to 1. So for 0, both the terms will be 0, and for 1, both the terms will be 1 and 1, like t and t cube and everything. So it is 2 times of 1 minus 1 by 3. So 1 minus 1 by 3 is 2 by 3 into 2 is 4 by 3. So 4 by 3 is the answer, and you will get the same answer here also, 4 by 3. But do you see that this will be a bit of calculation? So instead of that, using the property of even and odd function, the integration from minus a to a f of x dx becomes 2 times of 0 to a f of x dx if the function is even, and it is 0 if it is odd, right? You can use this property directly and you can find the value. So what is the answer? 4 by 3, which is C option. So you are using the property here. Correct? Done? So let's move to the next question. Yes. Let's try this one. You can do it by parts and you'll have to decide which one you have to take as u and which one you have to take as v. X ln x. You know, like if you're taking using the property of like, it's not a property, it is just a rough rule. So you can take log as u and algebraic term as v, right? So in that case, you are taking ln x as u and x as v. So this integration is going to be u, which is ln x, integration of x dx minus differentiation of ln x, which is 1 by x, and integration of x is, I'm directly writing it, x square by 2, otherwise we'll have to go like take one more step, this, right? And the limits are 1 to e. So this becomes ln x into into x from 1 to e minus this x and x square, like one terms will get reduced and it will be x square by 2 for the limit 1 to e. Right? So nothing much, you'll have to put the value. I think, what are the options? Okay, this is a decimal question, fractional question. So you'll have to calculate and find the value. This is x. Okay, this integration is x square by 2 because it is x, right? So putting the values, what we'll get? ln e is 1, so 1 into e square by 2, and ln 1 is 0, so minus 0. Of course 1 by 2 will be there, but multiplied with 0. Other than that, minus of x square, so e square by 2 and minus 1 by 2, this much. This will be 1 by 2 and 1 by 2 again. Let's write 2 square and 2 square, because integration of this This is integration of x by 2 dx. So this will be x square by 4. So 2 square 2 square. So this is going to be e square by 2 minus e square by 4, and minus plus 1 by 4. So overall this is going to be e square by 4 minus or plus 1 by 4. Calculate this. This is going to be something around 2.097. You need to make some calculations here, and it is going to be 2.097. 1.33, option C. Yes, 1.33 is right. Let's talk about this one now. I think there was some interruption in the chat box. I don't know what was it. Some technical error. I cannot control that. Right. So what is the answer? Do the calculations in this question. Of course, you have done the previous one. 1.33 was the answer. 4 by 3. Option C. What about this one? It is e square plus 1 by 4. If you make the calculation, it will be 2.097 approximately. Right. So let's move to the applications now. Yes, 1.33 is for the previous one. For this one, you are getting 1.33. This one, x ln x. For x ln x from e to 1 to e, you will get 2.097. Fine. 1.33 was for the previous one. That is 4 by 3. For the previous one, C option. That is done. This one, it is 2.097. Please check. The final integration is x square by 2 ln x and x square by 4. And the limits are e to 1 or 1 to 2. Right. 2.097. Right, Lokesh. Correctly said. Let's move to the next part. Now we are moving into, of course, we'll get back to it with some questions also again. But we are moving into applications of integration where we'll be seeing like, what do you say? Like how to use it. So it says the length of the curve where y is equal to this much between x equal to 0 to 1. This is what they are asking. Now we know one small thing about length of the curve is dx is given as dx square plus dy square, which is also given as, if y is function of x, we can also write it as 1 plus dy by dx square dx, right? And now we have this y is equal to 2 by 3 x to the power of 3 by 2, then dy by dx becomes 2 by 3 into 3 by 2 into x to the power of 3 by 2 minus 1. So this is 1 by 2. So this becomes under root of x. Right? If this is dy under root of x, dy by dx becomes, square becomes x. So this is nothing but under root of 1 plus x dx. And we know the limit of x from 0 to 1. Right? So using this, we can find the length of this curve given by y is equal to 2 by 3 of x to the power of 3 by 2. So this length, I'm writing it as s, is integration of ds will be nothing but integration of 0 to 1 under root of 1 plus x dx. And this integration is nothing but like t to the power of 1 by 2. So this is 1 plus x to the power of 3 by 2 divided by, let's say, 3 by 2. The limits are 0 to 1. So I'm writing it as 2 by 3. Putting 1, it will be 2 to the power of 3 by 2. And putting 0, it will be 1 to the power of 3 by 2. Find this value. You can make the calculation there and find it. I think the answer is around 1.218. Right? Finding the length of the curve. Moving to the next question. Let's check this one. So there's another curve, three-dimensional curve, where x, y, and z are all function of t, and t has a limit from 0 to pi by 2, and then you have to find the length of the curve. So in three dimension, again we can do it in the similar manner. This is dx square plus dy square plus dz square, and it can also be written as dx by dt plus dy by dt 1.218. Yes, and the option is 1.22. Right. For the previous question, D will be the answer, which is 1.22. So 1.218 is the approximate, like the closest one. So we'll go for option D. Now let's see what is dx, dy, and dt. So we have x of t is equal to cos t. So dx by dt becomes minus sin t. dy by dt is sin t. So dy, sorry, it is d. It's not dy by dt. It is y. Y is equal to this. So dy by dt is cos t and then 2 pi by t. Z is 2 pi by t. So dz is 2 by pi. Right? So in that case, we can directly substitute all these parameters and this will become, let's say it is sine square. The first one is minus sine t, but minus sine t I'm considering to be square, so I'm removing the minus sign. So I'm writing it sine square t plus cos square t plus 2 by pi square dt, and t has a limit from 0 to pi by 2. So this sine square t and cos square t will become 1, and this is nothing but just a constant, 1 plus 4 by pi square dt. That's it. So this is good that we have a constant here. We won't have to, like, we can take it outside if we have any calculations in between. So this ds is this. So the length of the curve is going to be integration of ds, which is integration of 1 plus 4 pi square dt from t equal to 0 to pi by 2. 2.207. Let me see. 2.207. It is 1.86. So you are taking this under root of 1 plus 4 by pi square common, and then inside, if it is dt, the integration of dt is simply t. So the limits of t from 0 to pi by 2 will simply become pi by 2. So I'm writing it as pi by 2. Like I have done that part of calculations outside and directly putting it here. So just use this calculators. You use your calculators. 4 by pi square is 0.405 and plus 1, under root of it is 1.185 into pi divided by 2 is 1.862. So this is 1.862. Clear? 1.862. Correctly said, Lokesh. So this is the answer. So again we did it like the same. It was the same question compared to the previous one, but the previous one was 2-dimensional. This one is 3-dimensional, but it is fine. It's the same thing. Let's move to the next question. A good one. This is a good question. It is a 2 marks question, but if you see, you can solve it like in 10, maybe like 20 seconds. I think you can solve it in 20 to 30 seconds for this 2 marks question. Just see this. All you need is a little imagination and understanding of the parameters. So let's say in this question we have to find the area of the surface generated. That is what they are asking. My point is, let's say that this pi u by 2 is some angle theta. Fine. And considering the limits of u being 0 to 1, this pi u by 2 will come between 0 to pi by 2. So this is nothing but theta lies between 0 to pi by 2. Getting my point? Theta considering pi u by 2, it will be in the range of 0 to pi by 2. So what we are talking about is x being cos theta and y being sin theta. X being cos theta and y being sin theta. And the angle moves from 0 to pi by 2. So if you remember, this x being r cos theta and y being r sin theta is nothing but the parameter of a circle, right? Because x square plus y square is equal to r square, and in this case r is 1 because this r comes here, r cos theta and r sin theta, but in this case r is equal to 1. This is why we have only cos theta and only sin theta, right? Pi, B answer. B is not the answer. The answer is 2 pi. Forget about it. Let's see this. So my point is this is a circle. Parameters are for the circle. So this parameters for a circle with theta being in theta equal to 0 and theta equal to pi by 2. So this is what you will have. This is your like 1 and 1, right? And now they want you to rotate this curve about x-axis by 360 degrees. So this is your x-axis, right? So you are rotating this about x-axis. What will happen? You will form a hemisphere, right? If you are rotating this curve y, or y is equal to this and x equal to this, about x-axis, what will happen? You will get a silly and tricky question. Exactly. It is a tricky question. You need to understand, and this is a 2 marks question. So if you understand this, this is a hemisphere and you need to find the surface area. So surface area of a hemisphere is 2 pi r square and r is 1. So this is going to be 2 pi directly. If you don't want to do any calculations, your answer is done. 2 pi is the answer, right? But if you want to solve it conventionally and find the values and everything, what you can do is, like, possibly next time they won't ask you this, but you should know how to solve such questions. So in that case, you need to find the circumference. Let's say this is the circumference. What is circumference? 2 pi r. So what will be r in this case? The r in this case is nothing but y. Yes, this is the y. This one. This will make a circumference. If you want to find the surface area of any curve, the formula is, let's say, surface area SA. Let's say like that. You need to find the circumference, which is 2 pi y in this case, and the length ds, because this is the length, this length, right? This one. This is the length. Correct? So my point is, in that case, if you are trying to do it like this, again you can still take ds is equal to like cos theta and sin theta, and ds is nothing but, you know, this under root of dx square plus dy square. You substitute this. Even if you are taking it theta instead of pi u by 2, then also you'll get the same thing. I mean, you don't have to do this du is equal to pi by 2 as d theta. It won't be required. Why I'm saying is because when you'll have this y, you'll have this integration and then that thing will get cancelled. This pi by 2 will get cancelled. So you can do it in this manner also. But I mean, you need an understanding, right? So ds is this one, the yellow one which I have pointed, and 2 pi y. So y is already given as sine theta. So you can use this and you can again calculate and you will again get 2 pi. Right, so you need to have an understanding of like what picture or what curve you are getting. Sometimes it helps you. So this 2 marks question can be like done in like 30 seconds maybe, or maybe less than that. Let's move to the next question. What was the option correct? B. B was pi. Yes. See, it is about the understanding that whether you are trying to find the surface area or area. Sometimes you think of area. So then in that case, it will be pi r square, right? And r equal to 1, you will get it. But they are talking about the surface area formed by the revolution. So when you revolve a curve, you will get a solid body. And when you get a solid, the surface area cannot be equal to the simple area of the circle, right? So maybe you are in case I'm saying in case you are getting anything like that, the first attempt is coming to the like option B. Once you like finish your vector calculus, you'll be very clear about these things. Vector calculus is very interesting, and this is how they use all these things, parameters and all. So let's see the next question. It says the area bounded by the parabola y is equal to x square plus 1 and the straight line x plus y is equal to 3. So of course in the previous classes also, like in the class of I think maximum, minimum and everything, we were discussing parabola and all a very lot. So let's talk about this y equal to x square plus 1. This is a parabola, right? So parabola, and this is plus 1. So you know this y is equal to x square. Y is equal to x square is like this, and when you have plus 1, you uplift it by 1 unit. So let's say my new curve will be something like this. This is the best I can draw, and I cannot spend more time on this. So this is x equal to, y is equal to 1. This is y is equal to 1, right? And next is the next line. So let's say this is y1. Next line is, from here can we write y is equal to 3 minus x? But of course you can find this straight line directly as x plus y is equal to 3 means x also has intercept of 3 and y also has intercept of 3. So let's say this is 3 and this is also 3. Let's say this, and let's join better. Let's say this is y2. So this one is y2 is equal to 3 minus x, and this is y1 as equal to x square plus 1, right? Now you can clearly see this, that if you have to find the area bounded will be this one. This is the area bounded by both the curves. And if you can also see in the y-axis, you can see this y2 is coming greater than y1. So what we can do is, finding this area can be given as y2 minus y1 for the integration of dx, and we'll have to find the limits of x. So how to find the limits of x? This is the point of intersection of both the curve, and this is the another point of intersection of both the curve. So you can equate y1 equal to y2. You can solve it by y1 equal to y2. So let's say at these points y1 equal to y2. So what is y1? It is x square plus 1, and what is y2? This is 3 minus x, right? So solve this and find the coordinates. Like, we don't have to find y, we have to simply find the x because we have to put it as limit. So this is x square plus x minus 2 equal to 0. So minus 2. If it is minus 2, we can write it as 2 minus 1. So x plus 2 and minus 1 equal to 0. So the roots are x equal to 1 and minus 2, which means this one is x equal to 1 and this is x equal to minus 2. So that means we have to make this integration from minus 2, x is equal to minus 2 to 1. That's it. So y2 y minus y1. So what is y2? 3 minus x minus x square plus 1 and whole integration as dx from minus 2 to 1. That's it. This will give you the answer. So let's start with the higher order. Higher order is x square, which is minus, so it is minus x cube by 3. The next one is minus x, no other term with the x. So minus x will have minus x square by 2. This 3 and this minus will have 2 as 2x when integrated, and the limits are minus 2 to 1. Put the limits and find the value. When you are putting 1, it is minus 1 by 3 minus 1 by 2 plus 2 minus, when you are putting minus 2, so minus 2 is 8 by 3 minus 2 will be minus 4 by 2 and minus 2. Find the value. If you see this is 1.5 and this is 6. So minus and like minus 6. So minus and minus will become plus. So it is 7.5 in the positive side. This is minus 1 by 3 and minus 8 by 3. So this is minus 9 by 3. So it is minus 3. So this is 4.5 or 9 by 2. Minus 4, sir, not minus 2. Which one? This one? Yes, correct. Minus 4. So this has to be minus 6. So the final answer is 9 by 2, and please check the options. Nine by 2 is the option somewhere. Yes, B option. So that means B is the answer. Correct. Anyways, the calculation part is up to you. Don't depend on me on the calculation at least. Good. So 9 by 2 is the answer, 4.5. Correct. So you can see that point of intersection is important, and you can find it by solving both the equations to be equal. And that's it. Let's check the next one. This is about the volume. Okay, we don't have to scroll that. Try this one. So it is about volume of the solid of rotation. That means when you will be rotating this curve, it will come like this. Right? It will come like this, and in that case you have to find the volume. And how to find the volume? The volume is area ds. What is ds? ds is the length. Right? So what is area? What area I am talking about? I am talking about this area, like this circular segment. Let's draw a smaller one so that this one. This is the area I am talking about, and this area will be pi y square. Why? Because y will be the radius, and what is y? Y is under root of x, like x is equal to y square, so y is equal to under root of x. So pi y square, so instead of y square we can, so that means y square is equal to x, so pi x. right? That's it. And in this case, you have to integrate it for this ds. In this case, what is ds? Ds is nothing but dx in this case, because we are like solving in terms of x here, right? So all you have to do is 9 by 2. So what will be the limit of x? X is clearly written as 0 and 1. So this ds is dx in this case. So pi x dx from x is equal to 0 to 1. This is pi x square by 2 from 0 to 1, which is pi by 2. So that is option B. Option C, pi. It's not pi. It is pi by 2, 0 to 1. Please check, Kirti. Yes, pi by 2, not pi. Correct? Why it is ds as dx in this case? Why are we writing ds as dx in this case? Because the element, they need not be like, if this is curve, what is ds? Ds is this part. This is dx and this is dy, right? So why are we writing ds instead of writing ds? We are writing dx because once you have taken your the area as pi y square, you need the width, right? You need the width because this is nothing but a small cylindrical element, right? So this is dx, this length, the radius is going to be y, and this area is going to be pi y square, correct? How dx came, that's what I'm explaining. Because in this case you don't need the length of this curve, right? What you need is the element. Like, how are you actually trying to find the area, volume? Let's say this is, let me explain you in the simpler method. If this is a cylinder, what do you say? How to find the area or volume? You will find the area of this circle as pi y square, and then what you do? You take a width. Let me take the width like this, right? So you take a certain width of this, and this is nothing but the height of it, right? Similarly, when you are, when this, like this is a simple curve of a cylinder, but when you have a curve like a parabolic curve here, so in that case this width is nothing but the dx. You getting my point? This width is nothing but the dx, because it does not have anything to do with ds. Correct? Dx is the width. You don't have to do anything with the length of the curve. That's what I was explaining here, na? This is ds, this is dx, and this is dy. So you don't need dy here, or sorry, you don't need ds here. But in the previous part where we were discussing the what is that, surface area. Now when we are actually discussing the surface area, you will have to take the circumference, but the circumference width will be ds, because that is the length. You are trying to find the area, so it will be length into width. So in this case, the length will be not like this. Let's say this is ds, so this is dy and this is dx. So in this case you need the length like this. If you remember this, when you are trying to find the surface area of a cone, I'm just trying to relate it with some example you have already known. You write the area to be pi r l, and what is l? L is the slant height. Why don't you write height? You don't write height, right? Because when you are taking an element, When you're taking a small circumference element, you take the slant height as ds. Getting the point? You take the slant height. You don't take a width. You don't take a simple width or height. You take a slant height as this, like this. So this slant height gives you pi r L and not pi r h or something like that. That is the difference here, right? So it is up to about whether what you are trying to find and what are the parameters also, that also help you, right? Apart from that, we'll also try to solve some of the like other, I'll say, indefinite integration. Let's talk about this sine mx cos nx dx for whatever integration interval it is. See, it is about the odd and even powers of these functions. Like in the previous case, we had sine cube theta. So what we wrote as sine square theta into sine theta and d theta. Why? Because this helped us to make it as dt, right? In a similar fashion, if we have, let's say if we have cos 5 theta, like cos 5 power 5 into sine cube theta d theta. Again, what you can do is you can keep this cos 5 theta and write this sine as sine square theta into sine theta. And again, you can take as cos theta is equal to dt. So that you can remove this from as minus dt. This will be t to the power of 5 and this will be 1 minus t square, right? So all such trigonometric functions of cos and sine, like what if we have both, like if we have like maybe sine 4 theta into cos theta, very simple, because now you have cos theta d theta, you can directly take sine theta as t and you can make this as dt. So you have to see which one is your odd power, which one is your odd power, which one is your even power, because this odd power can be taken out, making it as dt or dx anything, so that you can substitute something. But what if you have both the terms to be like, let's say, let's go down. What if you have both the terms being even? Let's say you have sine 4 theta. So in that case, what you can do is, we know some formulas as 1 plus cos square theta as 2 cos, it is 1 plus cos 2 theta, 2 cos square theta, and 1 minus cos 2 theta as 2 sine square theta, like that. So if it is sine to the power of 4, you can write it as 1 minus cos 2 theta by 2 to the power of, let's say, square. Then you can split this and you can calculate this, right? Yes, 1 plus cos 2 theta is 2 cos square theta, 1 minus cos 2 theta is 2 sin square theta. So instead of this, what we can do is we can write this. And if it is even power of only cos square function also, then also you can use this formula. Otherwise, if it is sine, you can use this formula. So these are all how you can expand this and you can solve this, right? Other than that, one more question I'll take, that is integration of, let's say, indefinite integration as tan inverse of x dx. So some of the time you have to use by parts, but also you have to take care that once again, but you have to also take care, like instead of tan inverse of x, you can write it as 1 into tan inverse of x dx. And you know that differentiation of tan inverse of x is like known, so you can take this one as u and this one as v. So what we will do is tan inverse of x into integration of 1 dx minus differentiation of tan inverse of x, which is, let's say, 1 plus x square, and then x dx, like this. So now it is very possible you can take 1 plus x square as equal to t, so you'll have 2x dx is equal to dt. So put 2 in numerator and denominator and you convert it into dt. This is like already done. This is tan inverse of x into x and minus like this, all this thing, right? So in this way you can actually solve it. Like some of the time the functions are like this, so that you will have to take one as the, like you'll have to do the by parts, considering another function being 1, like we have done in this case, right? And of course there is a, like, just have a look on the chart. Yes, of course there is a table and some of the applications you can do. This is just for your reference. You must be having this table. You can use it anytime, and you can see the properties also. Like we have some more integrations, and this also, and maybe some other properties. So these are some of the properties. Some of the major properties you will come across is this one, which we used today also, this one. And of course these are like the conclusions of the previous one. So these two properties are important. Other than that, this and all. So we'll be winding up here, and my suggestion is you'll have to practice more questions on this, no doubt, and more, like mostly they'll come up with substitution method or by parts, and they don't make so much of use of the properties of definite integration, but some of the two properties which I highlighted, they'll definitely be using it, right? They'll definitely be using it. In the next class we'll be discussing multiple integration. One second, there is something. Yes. So in the next class we'll be moving into multiple integration, double integration, triple integration, and then changing the order of integration on all those tasks, because they'll be asking you on, like, on this topic. And after that, that will help you to switch into vector calculus also, right? So you can also share this link with your friends and put a thumbs up on the video, and of course practice more question on this topic. Of course we have given an idea on what depth they are looking on, but this is all you have to do. Okay. Okay then, thank you.